My name is William Chung. I'm a trained landscape architect. This is a unique project, to say the least, in my career. We were brought in April of last year by request of Department of Defense to look at helping them to rebuild and recover the Tyndall Air Force Base. First of all, I'm going to give you a little background in terms of what we're looking at. Tyndall Air Force Base, geographically located in the western sort of Panhandle area of Florida. It's uniquely sort of in the middle between Pensacola to the west and Tallahassee to the east. In early October, within only a 48-hour notice, they were told the Hurricane Michael will be heading their direction. In a way, it will be a direct hit, to say the least. So in terms of the way how the site is situated, a large segment of the Tyndall Air Force Base, over 30,000 acres, consists of natural beachfront and untouched dune restoration area. So we're looking at protecting some of these ecosystems as part of the strategy of what we're doing for the Tyndall rebuild system. And as you see, most of these areas are fully integrated natural ecological system that we are trying our best to remain left it alone the way how we're going to integrate the rest of the system. And also, a little background in terms of what Tyndall Air Force Base is doing. Currently, since 2005, they host 3 squadrons of the F-22, which is the most advanced stealth aircraft in U.S. inventory, as well as both manned and unmanned aerial drones like the QF-16 and the QM-167. As it transitions over the next 5 years from the F-35 new joint use combat aircraft to also the unmanned mission of the MQ-9, we're looking at in terms of how to utilize these understanding in terms of what the different weapon system to design the facility suitable for these assets to be located. Now, in October of 2018, Hurricane Michael, which is with the sustained wind over 155 miles an hour, Category 5, with storm surge up to 9 to 14 feet, hit Tyndall directly. It was probably one of the last few Category 5 hit over the continental U.S. in the last 10 years. And this is actually an interesting photograph that I was able to show. The F-22 you see was hastily put together. Most of these are stranded aircraft right before the hurricane, over at $250 million piece, including research and development. The photograph represents an asset value of over $3 billion. Ironically, it was situated in an 80-year-old hangar facility built in World War II. So this is kind of the basis of what we have to deal with. A very expensive assets, but not a sort of antiquated system in terms of the facility for the Air Force. So this is the same location, same facility afterwards. Half the roof was peeled off. Fortunately, most of the aircraft was subsequently repaired and put back in missions. So the external view of that same facility we showed earlier. In the aftermath of the hurricane, over 95% of the structure was affected. Almost half of the facility was completely destroyed, and with the remaining heavily damaged. Aside from just the structural side of the site, we're also looking at, on the facility side, a lot of the older facility, because the way how it was built, was not able to withstand the hurricane wind condition. And also the infrastructure aside, we're looking at recovery required to rebuild Tyndall was not there. So in the process of this master plan, we're looking at to rebuild the entire infrastructure and make it much more robust and redundant. On the human side of it, this is the area just east of Tyndall at the Mexico Beach. The devastation was complete and total. Over 90% of the facility was completely destroyed beyond repair. And from this lesson, we learned, aside from just building the Tyndall Air Base, we also need to recognize the need to looking at the community surrounding the air base, how to help them recover in the process to bring the resources needed for the reconstructions. aside from the natural environment side of it, over 7,400 acres of slash pine, these are the sort of non-native vegetation that was introduced in the past 50 or 60 years, was completely clear. So we understand the need to bring in more sort of native and indigenous material as a way for the part of that whole reconstruction. In the early assessment phase of the project, we also analyzed in terms of different historical events, all the past hurricanes that have affected the Gulf region, understanding how to reinforce our design to re-anticipate some of the events that are taking place. The event here at Tyndall, along with other sort of critical things that take place to the air base or installation around the U.S. over the past 3 or 4 years, have finally compelled the Department of Defense to recognize the whole paradigm shift in terms of understanding the defense against weather event anticipated from the sea level rise as well as climate change is far more devastating than even in a conventional critical conflict. So looking into the whole holistic strategy, Jacob was able to bring in over a staff of 250 engineer, architect, landscape architect, programmer, planner, as well as environmental specialists. We're looking at the whole approach of resiliency, sustainability, and smart technology incorporated into the concept of our master plan, making it much more connected and much more inclusive in terms of the way how this was built, and as well as the surrounding community, and making it also more competitive in terms of the way how it delivered the type of air bases needed for the air forces, and also making it obviously much more safe and defensible against any future critical weather event, and to also utilize resourceful both nature and man-made in the way how this master plan was put together. So some of the early stage of our assessments looking at analyzing the different effect of the storm surge resulting from the hurricane. As we finally recognized some of the storm surge coming from the hurricane not necessarily is really where the direction where the hurricane come from. Some of those flooding actually occurred in the inland bay system, which is a little bit different from what we have anticipated all along. So as we go through the analytical phase of that, early on, we brought in a lot of specialists, and with some encouragement from our director of geospatial technology, Shannon McAvaney, we were able to convince the Air Force for us to incorporate the geospatial technology during the design phase of the reconstruction of the Tyndall. Now, part of the understanding of using the storm surge analysis to help us locate or relocate critical facility away from this effect of the flooding. So in a way to identify much more optimum location where the new facility will be located and to stay away from impending effect of either flooding locally or on the regional area. We also identify in terms of, from modeling, the ultimate location where all the future buildings need to be situated in order to avoid any kind of repeated flooding issue related to what some of the existing facilities have suffered. So early on, when we're looking at the concept phase, we were able to incorporate some of the existing sort of planning concept related to making the campus much more robust and much more also pedestrian friendly. One thing we did is making the campus overall much more compact, eliminate some of the unused parking lot to reduce the overall heat island effect, and to minimize any kind of conflict point between the pedestrian as well as the vehicular traffics. We also incorporated much more nature-oriented system to use it as a way, along with the man-made system, to design around the perimeter for the campus. Overall, the nature of the campus, we make the sort of the mission side of the campus what we refer to as a flight line, much more robust, muscular, in terms of having built-in redundancy on the infrastructure side to allow a much more plug-and-play option for the new facility or future facility put in place. On the support side, on the diagram I'm showing on the screen here, most of the connection between buildings are much oriented towards the walking to try to eliminate the need for people driving, so in a way to make the site overall much more capable in a way how to allow the different staff or airmen working and living on campus. It's a little different approach overall, and the way how the legacy sort of design system that Air Force has been using. Now, one of the things we also do in part of this project is to revise the infrastructure facility standard. So the sort of old way of cookie cutter type of base design that was advocated by the Air Force is now kind of put upside down. We have to regionally looking at localize all the design to anticipate in terms of what we're doing in an event for another future, either flooding or hurricane or even an earthquake might actually affect this facility. So before I'm going to hand it over to Eduardo for the more detail on the assessment phase, what we're doing.
Good job, man. Thanks. Good morning. So when I'm not working on this project, I'm flying one of those. Just kidding. I'm just a planner and maybe a tree hugger. But the point is that this project is actually bigger than that. It's bigger than an air base. It's kind of the talking that we need to consider when we're thinking about resilience, right? So, relic dunes, very interesting project and concept. So many great examples of how we can apply this concept along the coastline, right? It looks silly, but it works. It makes sense. It's actually something that we're considering in this project. And we did the calculations, we did all the work behind this proposal. We probably wouldn't have a lot of biomass, but it will be great as a second line of defense. And we have the numbers, we have the models, and it makes sense. So we found a couple of potential pilot projects locations where we can implement these ideas along the area. So now that we have an idea of how we can protect Tyndall, let's bring those landscape management concepts to start, creating scenarios, to start, negotiating and, compromising sometimes, to come up with the best scenarios for this project. So we have two concepts, business as usual and nature-based concept. So the business as usual, very low intervention in terms of revegetation, basically grass, some long-leaf pines, but we should have the same expectations if something like Michael's happens again. In the nature-based concept, we have high intervention of revegetation in terms of native species along the areas, and we should have better expectations if something like Michael's happens, right? Especially because this concept has the essential elements of biophilic, right? So we create natural spaces that keep us curious, right? That give us benefits overall. Cognitive experiences actually related to being around nature, and it gives us, rewarding experiences for sure. So that sounds great. Let's see the numbers. So if we implement the business as usual concept, we can reduce the stormwater by 261 million gallons per year. On the other hand, if we implement the nature-based concept in this area, we can reduce the stormwater by over 1 billion of gallons per year. So big difference, right? Big difference. So same thing happens with air quality, energy savings, carbon reduction, but now with maintenance. In maintenance, it's actually the business as usual more expensive, like 3 times more expensive than keeping the nature-based concept in a year. If we consider the overall vegetation benefits between these two scenarios, we have that the nature-based concept produce 4 times more benefits overall than the business as usual concept. It's about $16 million a year. So we like to see numbers. We like to see, how we can compare this. We want to see how ecosystem services works in this type of scenarios, right? We want to see cost, benefits. But there is always something more than that. I think everything that we design us back, design us in return, right? So we need to start acting accordingly, right? For example, this is a land surface temperature in Tyndall. The highest temperature right now is about 90.5 degrees, with an average of 75.9 degrees. So if we implement the land surface temperature using the concept of nature-based, we can expect the highest temperature be lowered by 3 degrees, just by using that concept. And the average temperature will be about 94.3. This means that people will, walk more, bike more, feel more connected to nature, enjoy being outside, right? That changes everything. If you consider just this, right? This example. So now, we need to keep the conversation going. We have the tools to do it. We need to track the rebuilding process with the tools available. So we have all these dashboards, web services, to deliver information almost in real time to the stakeholders. So Tyndall will perform at its best. It's like being in its flow, right? It's gonna flow with energy. It's gonna be more resilient, for sure. It's gonna be resilient to extreme weather, and it's gonna start feeling alive. Not just because all the beautiful wetlands and trees that we're gonna, think and implement, but also because people will feel more connected to nature, which is actually what really matters. Designs matters. So let's watch this. That's going to be Tyndall, the base of the future. Thank you.